Hi class, welcome to week 2, and this week's advanced concept presentation is going to be talking about lava lamps. I'm actually going to attempt to make one myself. We all had lava lamps as kids, and I guess I never really thought about it, but the two concepts that work when we're talking about lava lamps are density and polarity. Density is how compact a substance is, and polarity is has to do with the separation of an electric charge. So like water molecules have kind of a lopsided electrical charge. They have a positive charge end of the molecule that has the two hydrogen atoms, and then the negative charge end is the end with the oxygen. Oil molecules, on the other hand, are nonpolar, which means they don't have a negative or a positive charge, and so that they are not attracted to water. This is one reason why water and oil don't mix. Also, water is more dense and tends to sink below the oil. So that is another example of density. So in the old time lava lamps, heat was used to melt wax, and then the heavier liquid would absorb the heat, and then it would expand, become less dense, and then the wax globs would rise up to the top of the water, where then they would rise, and then they would cool, and they would fall back down to the bottom of the lamp again, where they would heat up again, and then they would keep doing this over and over again. It was like a continuous loop, because there was the one nonpolar substance with the polar substance. So anyway, so what we're going to do today is to create a lava lamp without using electricity. Instead, we're going to use a common household item. I know I keep these around, using Alka-Seltzer tablets. The Alka-Seltzer is made up of 3 ingredients: aspirin, sodium bicarbonate, and citric acid. So the citric acid, when it hits the water, well, actually citric acid is going to react with the sodium bicarbonate with the water, salt, and create a carbon dioxide gas. And I'm going to hypothesize that when this happens, the little bubbles are going to raise up the drops of food coloring, which I will be adding to my mixture, and the gas it'll bubble up to the top, and when the bubbles pop, then the color will sink back down to the bottom again, and in that way the Alka-Seltzer is going to be the limiting reactant in this experiment, because when the bubbles from the Alka-Seltzer were off, the reaction stops. So what we're going to do here is actually we're going to fill the bottle about 1/4 of the way with water. So I just put some water in a measuring cup, because I actually used my oil bottle, because I kind of thought that would make a cute bottle in itself. So now I'm going to pour the oil back in. There's no exact amount to use other than to leave some space at the top for the color to rise up and sink back down again. So there, you can see the water at the bottom. Now, I sent my darling husband to pick up some food coloring for me from Publix the other night, and as any good husband would not be expected to know, he came home with gel food coloring, but I'm going to use it anyways, because I predict that it will still dissolve in the water. Not really sure exactly what it's going to look like, but I'm going to go ahead and boop. There you go, it's sinking. Actually, it's sinking easier than the regular food coloring. I don't know, that's probably about 10 drops, but I guess I can help control the effect of how much color by how much food coloring I put in. That would be one thing that I could do. Okay, so now I don't really have to do much because most of it is down at the bottom. Actually, I'm going to add a little more because I really like pink. Okay, and then I have my Alka-Seltzer. So like I said, we're going to start adding this in. And I broke it into a few pieces so that it could get to the bottom. Let's go ahead and do this. I'm going to put the lid on here for a second. Give it a little swirl. Okay. There it goes. I think that the gel food coloring needed to dissolve a little more, but now that it is, you can see the bubbles are creating the reaction when the citric acid in Alka-Seltzer reacts with the sodium bicarbonate, forms water, a salt, and bubbles of the carbon dioxide gas. And when the Alka-Seltzer is used up, those bubbles will stop, everything will sink back to the bottom. Therefore, the Alka-Seltzer is a limiting reaction. So, this is my experiment. So, and I have the lid on there, so I'm kind of creating an enclosed environment. So maybe some of that gas stays in there a little longer. But if I take the lid back off, let's see what happens. Whoa, now it's really bubbling. So, and I predict that will run out faster. Anyway, thank you for enjoying this advanced concept presentation with me. See you next week.